Example 1, adult sleep. The author obtained times of sleep for randomly selected adult subjects included in the National Health and Nutrition Examination Study, and those times hours are listed below. Here are the unrounded statistics for this example, or for this sample. The sample size n is equal to 12, the sample mean is 6.83333333, and the sample standard deviation is 1.99240984 hours. A common recommendation is that the adults should sleep between 7 hours and 9 hours each night. Use the p-value method with a 0.05 significance level to test the claim that the mean amount of sleep for adults is less than 7 hours. We're also going to use the critical value method in here just so that we can see both of them. Now, one way of looking at this is we can enter this information into statcrunch. So if I come in here and I'm going to put in a column, right, sleep hours, and I'm going to put in the values 4, 8, 4, 4, 8, 6, 9, 7, 7, 10, 7, and then 8. And just to verify the mean and the standard deviation, okay, if we select stat, go to summary stats and select columns, and then let's just go ahead and select the column, put in n, the mean and the standard deviation, and when we select compute, you're going to see that we get 12, we get the same mean, and then we get the same standard deviation. Okay, now, first and foremost, we want to identify the values, which we do. We have n, x bar, which is the sample mean, the sample standard deviation, because this represents the sample. Now we need to check the requirements. It says here the sample is a simple random sample. The second requirement is that the population is normally distributed or that n is greater than 30. Now the sample size is n equals 12, which does not exceed 30. So we must determine whether the sample data appear to be from a normally distributed population. So what we have to do is we're going to have to use statcrunch to graph the histogram and the normal quantile plot along with the apparent absence of outliers to indicate that the sample appears to be from a population with a distribution that is approximately normal. So it's important to make sure that we have this data in here. So the first thing we're going to do is we're going to go ahead and then graph the histogram. So we're going to go to graph, select histogram, select sleep hours, and then we can start. Let's go ahead and just click. We want a frequency histogram, so we're going to select compute, and there is our histogram. So let's go ahead and copy that. So there is our histogram. So let's make sure we have our histogram here. Okay, and then we got to do the QQ plot. So we're going to go to graph, go down to the QQ plot, make sure we select sleep hours, use the horizontal lines and vertical lines, and then select compute. And then this is going to tell us whether it's approximately normal or not. So we have both, and if we look at that, there's a line that's drawn in there that gives us an approximately normal distribution. So we can see that it's approximately normal. It's not exactly normal, but it is approximately normal. So those are the two things that we need to verify because of the fact that n is less than 30. Okay, now we can say that both requirements are satisfied. So now in step 1, we want to state the claim and the opposite of the claim. Now the claim is that the mean amount of adult sleep is less than 7 hours becomes mean, which is less than 7 hours. So the claim is that mu is less than 7, and then the opposite of that would then be that mu is greater than or equal to 7. So you want to find out where the equal is located. So the equal is located in the opposite, and so therefore that's going to be in the null hypothesis. So the null hypothesis always contains the equality, so the mean is equal to 7 in the null. And therefore the claim where the mean is less than 7 is now going to be in the alternative hypothesis. So now in step 2, we can then identify the null in the alternative hypothesis. So again, the null is the mean is equal to 7, and the alternative is that the mean is less than 7. So now we want to move on to then step 3. Step 3, we want to use the alternative hypothesis to determine whether it is a left, right, or two-tailed distribution. This is a left-tailed distribution since the alternative hypothesis contains the less than inequality. Number 4, we want to select the significance level, alpha. If we go back to the question, okay, does it tell us that we have, here it says use a 0.05 significance level, so therefore alpha is equal to 0.05. Now we want to be able to find the test statistic for testing a claim about a mean. So using the given information that we have, we know that the sample size n is equal to 12. We know what the sample mean is, 6.83333333. And the standard deviation, the sample standard deviation is 1.9924094. Now we're going to go ahead and plug those values into the formula. So let's go ahead and do that. So we have the sample mean, and we're going to put the sample mean there. And then we're going to subtract mu. So let's go ahead and write that down here so it's in our information. So we know that mu is equal to 7. So therefore that represents that value. And then we're going to divide that by the sample standard deviation, so the sample standard deviation, and then divide it by the square root of the sample size, which is 12. So let's go ahead and do that on our calculator to determine what the test statistic is going to be. So we're going to take 6.83333333 and then subtract 7, and that's what we get in the numerator. And now we're going to divide it by that. So we're going to divide it by, and then let's put in parentheses, and then put a second parentheses to put that one, the standard deviation, 1.99240984 parentheses, and then we're going to divide that by, and then parentheses, the second square root of 12, and then put that in parentheses, and then we still need to put another parenthesis to contain the entire denominator, and then press enter, and we get negative 0.289775 rounded to 6 decimal places. But we want to round this to 3 decimal places, so we get negative 0.290. So there is our test statistic. Okay, so now the next step is we want to be able to then draw and label the curve. So we're going to do the p-value method and the critical value method for this problem. So let's go ahead and start with the p-value method. So the first thing we want to do is draw our bell curve and then label everything that we have here. So drawing our bell curve, and since we have a t test statistic, we know that the mean is going to be 0. And then let's determine where our test statistic is, which is negative 0.29, so it's going to be to the left. And we also know that our test statistic and our hypothesis should be on the left side because it's a left-tailed distribution. So now let's go ahead and highlight the area that we're looking for. So we're looking for this area here. So we want to find the p-value. So the p-value is then going to equal the probability of when our t-value is going to be less than negative 0.29. So let's go ahead and use statcrunch. Now you can use the t-distribution, the student t-distribution for the table if you want to. We're going to use statcrunch here. So let's open up statcrunch, and then what we're going to do is we're going to go to stat, calculators, and since we are looking for the t, we have the t-value in order to find the p-value here, so we need to find our degrees of freedom. So what are our degrees of freedom? Well, the degrees of freedom is the following. We know it's going to be n minus 1. So we know that n is 12, so 12 minus 1 is going to give us 11. So let's go ahead and put that in there now. So we know our degrees of freedom is 11, and we know it's going to be less than or equal to, and then we're going to put in our test statistic to be negative 0.290, and therefore there we get our p-value. So let's go ahead and copy that p-value. So if we round that to 4 decimal places, we're going to see we get 0.3886. So now we can make a decision here by using the p-value and then comparing it to the significance level. Now recall that we reject the null hypothesis if the p-value is less than or equal to alpha, which is a significance level, and we fail to reject the null hypothesis if the p-value is greater than alpha, which is a significance level. So comparing the p-value versus alpha, we get the p-value to be 0.3886, and it's greater than 0.05. Therefore, we fail to reject the null hypothesis. Now, let's see what this looks like when we're using the critical value method. So for the critical value method, we want to find the critical value for the significance level of 0.05. So the first thing is that we need to do is find the degrees of freedom. The degrees of freedom is 12 minus 1, which is equal to 11. And we know that alpha is equal to 0.05. Now, since this is a one-tail, we're not going to divide this by 2 because it's only a one-tail. And we can use statcrunch to find that critical value. So let's go ahead and do that. So again, we're using the T calculator. So I'm going to go ahead and select refresh. Okay, and then we have our degrees of freedom, which is 11. And then since this is the alpha is 0.05, we want to make sure that this is the critical value on the left. So we're going to put in 0.05 and then select compute. And then we get negative 1.796. So therefore, let's go ahead and copy that critical value here. And so therefore, the critical value, which is positive, we get 1.796. But since this is a left-tailed, so the actual critical value is going to be negative 1.796. Because we're looking for the left critical value. So let's go ahead and then draw our bell curve with those values. So here's our bell curve. We know that the mean of the t distribution is going to be 0. And then let's put in our critical value. So our critical value is negative 1.796. And so then now we need to determine where the critical region is. So here is our critical region. So let's go ahead and then note that. And now let's go back and take a look at the test statistic. Well, the test statistic is negative 0.290. And so negative 0.290 is closer to 0 over here. So negative 0.290 is the test statistic, and we can see that it's not in the critical region. So in order for us to then determine here, recall that for the critical value method, we reject the null if the test statistic is in the critical region, and then we fail to reject the null if the test statistic is not in the critical region. And as you can see here, since the test statistic of negative 0.290 is not in the critical region, then we fail to reject the null, which is the same thing we got for the p-value method. Now we're going to state the conclusion. Okay, so if you recall the claim back up here, when we look at the claim was where it was less than, so it doesn't contain the equality, and we fail to reject the null. So that means we're going to look at this second one here. And so let's go ahead and then highlight that. We can see that the original claim does not include equality, and we failed to reject the null. So therefore we would say there is not sufficient evidence to support the claim that followed by the original claim. So therefore we would say because we failed to reject the null hypothesis, we conclude that there is not sufficient evidence to support the claim that the mean amount of adult sleep is less than 7 hours.